Hello. For the second half of the week, we're going to be doing domain and range. So this is just a quick refresher from last week with function notation. If this confused you on the quiz, this is how you do it. So when using function notation, if they give you a number inside the parentheses, they're giving you x. So they want you to plug it in to the equation. But you have to make sure that you're plugging it into the right equation. So remember, these letters are the name of the function. So this is a g function. So they want you to plug 2 into the g function and see what y is. So, because remember, function notation is all about inputs and outputs. 2 is our input, and we have to see what we would get out. So 3 times 2 is 6. You add it to 9 and you get 15. So that means that g of 2 is 15. If you plug in 2, you get out 15. For the next one, that's f. So they want you to use the f function and plug it in. Please be careful with negative stuff, okay? So this is negative 3 squared. A lot of people would think, oh, negative, they cancel out. Well, not so much, because order of operations says that we square things before we multiply them. So negative 3 squared is going to be positive 9. And then I would do that. So if that confuses you, please use a scientific calculator or GeoGebra if you don't have one, because they know the order of operations, even if you struggle with it, which, it happens. Okay, so negative 3 squared is 9, and then I have to make it negative, so I get negative 9, and then 3 times negative 3 is negative 9 plus 2. Add all those together, negative 9 is negative 18, 16. F of negative 3 is negative 16. If you plug in negative 3 to the f function, you get out negative 16. It says to write it as a coordinate pair. So in this case, it would be the point 215 would show up on the graph of G, and this one would negative 3, negative 16 would show up on the graph of, can't see what I did, on the graph of F. So for the second part, when they don't give you the X, right, they're saying it's equal to Y, they're saying that was the output, so that's the Y. So they want you to set the equation equal to 18. So g of x, which is 3x plus 9, equals 18. And then I solve. So please remember, well, you have to do the same thing on both sides of the equation. I suggest drawing a line to keep yourself organized. So I get 3x equals 9. And if I divide by 3, I get x equals 3. Can't remember. Okay. So what that means is that if you were to plug in 3, you would get out 18. So the point 318 shows up on the graph of G. Awesome. Okay. So that's function notation. So with domain and range, we're going to kind of talk about, because domain and range we're looking at graphically. So we're going to kind of talk about what is a function based on the graph. So the actual definition of a function would be that every input has only one output. So in other words, every x has only one y, okay, on the graph. So the way to test that is something called the vertical line test. What that means is if you draw a vertical line, sorry, brain. If you draw a vertical line, if there's anywhere where it will touch 2 points at the same time, then that means that they both have the same x, so they are not, it will not be a function, okay? So like, for example, this one. So there's a vertical line. I wonder if I can move it. Nope, it won't let me. That would have been cool though. Oh well. Anyway, so there's actually a couple places here where if I draw a vertical line, kind of a crooked vertical line, it touches, yes, I'm pointing at it. It touches 2 points at the same time. So that means that when x is 2, there's 2 different things that are y. So it's not a function. It doesn't fit the definition, okay? Because with equations and stuff that we're used to working with, when you plug something in, you'll get one thing out. So that's what we mean by function. For the second one, pretty much anywhere except for at 0. If you put a vertical line on this graph, you are going to end up touching more than 1 point. So when x is 1, 2, 3, 4, or any number in between, there's more than one value of y. So not a function. Now this last one, even though it gets really steep, if you do a true vertical line, it's only ever going to touch one spot, right? It gets really steep of it. My vertical lines are kind of crooked, sorry. Anyway, they're just so slanty. So, words. It's only ever going to touch 1 point though, if it's truly vertical. So this would be a function. Okay, so your answer would be yes. This one would be no, no, yes. Cool. All right, domain and range. What is it? Well, domain is a description of all the inputs or x's, if you will. So therefore range is the outputs. It looks like no. Outputs or the y's. Okay, so we're going to find ways to describe all of the x's that are on the graph or all of the y's that are on the graph or whatever. Okay, so the best way to do this is to basically show you what I mean. Okay, so on your work this week, it's going to ask you 3 things. It's going to ask you, is it a function? And then it's going to say, what's the domain and what's the range? We're going to use inequalities to do domain and range. So first off, is it a function? If I draw a vertical line, or a crooked vertical line, not quite vertical, but almost. Oh my gosh, there's another one. Oh, there we go. I clicked it. There we go. It only ever touches at, well, it's a curvy line. Okay. It only ever touches at 1 point. So we are going to say, yes, function. It is a function. Okay, so then for domain. Now, remember that domain is my x-axis. So here's my x-axis. If I look at my graph, everything, it does not go past 0. Okay, it goes 0 and then it goes forever in that direction. So in order to describe that, I'm going to say that all of the x's are greater than or equal to 0, because it starts at 0 and then it gets bigger forever as far as the x's are concerned. Okay, the x's go forever bigger. Sorry. For y's, domain. Okay, let's do blue for y. So for, did I say domain? Range. In this case, I'm looking at my y-axis. So I'm looking at the numbers on my y-axis. So here, it's never going to go below 4. So it starts at when y is 4, and then it goes up forever. It may be going up slowly, but it's never going to stop going up. Okay, so it goes forever. So I'm going to say that my y are all going to be greater than or equal to -4. Now I put the line under it because there is a point at 0, -4. The only time you wouldn't put a line under there is if you had an open circle. Okay, so my y's are greater than or equal to -4. Okay. This one. So Sorry. Function. Is it a function? I'm going to say yes, because no matter where I draw a vertical line, it only ever touches once. So for domain, there's no arrows going off, so it's between two numbers, right? It's just between two specific numbers. So I'm gonna like kind of draw some boundaries here. It goes from 2 to 5. So how do I write that as an inequality? Well, you're gonna put x in the middle, and then you're gonna use two less than symbols. So you're gonna use, because you're saying that 2 is less than all the x's, which is less than 5. So if you have two numbers that it's between, you always want to put x in the middle with two less thans. Cool. So it's going to go from 2 to 5. Now here, there's an open circle. So that one's not going to get the line under it. That's what I was talking about. It doesn't actually touch it too. For 5, it's a closed circle, so we will say or equal to. Cool. All right, for range, we're looking at the y, so I want to see, how low to how high. And just so you know, we always go from least to greatest with domain range. Excuse me. And generally, pretty much, I just go from least to greatest. So for my range, the lowest it goes is -2. You want to put a less than or equal to, because it does have a dot there. I'm going to put y for range, and then the highest it goes is 1. Cool. Cool. Awesome. Okay. So here's another one. Is this one a function? Well, no, it is not, because there are several places where I can draw a vertical line and touch more than once. So it is not a function, but we still got to do domain range. It still has a domain range. And just so you know, when something's not a function, it is called a relation, because it's where all functions are relations, but all relations are functions, because there's two variables that are relating to each other in some way. Does that make sense? Anyway. Okay. So, domain. X's. If you'll notice, domain. So we have to look at what's happening here. So we're looking at the x-axis, and if you notice, it does not ever go past 15. Okay? And since everything's to the left of it, that means that all the x's are smaller than 15. So in this case, x is less than or equal to 15, because there's no open circles. Now, if you're bad at less thans or greater thans, if you go like this with your hands, you make less than with your left hand. It's probably backwards for you. But your left makes less than. Greater than with your right hand. Anyway, but yeah, that's how you know if it's less than or greater than. Also, less than kind of looks like a little slanty L, if that helps. Greater than would be the other way. Also, it's a mouth and it's eating the bigger thing, so whatever. Anyway, so domain is x. All the x's are less than or equal to 15. It's everything under 15. For my range, if you'll notice, it is going forever in both directions. So what's actually happening is it's going off into infinity. Infinity is not a number, it's a concept. It means forever, never ending. So it's going up and down for forever. It will never stop. So if you end up with arrows going in both directions, up and down for y, side to side for x, what you are going to say is that the range is all real numbers. For those of you who don't like to write words out, which I get it, I'm a math person, you could put ARN, I will know what you mean. There also is what's the word I'm looking for? Like a symbol. A symbol that means all real numbers. It's technically an uppercase bold R. So you generally do 2 lines to signify that it's bold and then R. That if you ever see that in the context of math, it means all real numbers. There's like one for all the different major number systems, like Z is integers, Q is rational, I think. It's been a while. Anyway, but R is all real numbers. So, okay. So this one, it's got arrows going in both directions, okay? But we got to think about this. Well, first off, is it a function? Heck yeah, it is. I can draw lots of vertical lines now, only ever touch once. Cool. Vertical line, vertical line, vertical line. Boom. Function. Awesome. Okay. So, yes. Hooray. I don't know why I get so excited. Anyway. So for domain, we got to think about it in the context of x's. So from left to right, going this way and this way, it is going forever in both directions, left to right. So I'm going to say all real numbers. I'm just going to write ARN in parentheses. You do not have to do both. You can just put one or the other. I don't know what you mean. For range, I have to think of it from low to high. So how low does it go to how high does it go? Well, it's going forever in both directions. Sorry. Again, it is all real numbers, ARN, or just bold capital R. Again, you don't have to do both. I just want to give you options. So, fun fact, we were talking about linear functions week before last. So the domain and range for every linear function ever, unless given specific constraints, is always all real numbers. All straight lines go on forever in both directions, unless you have a vertical line, in which case that's vertical. Unless you have a vertical line, in which case the range would be all real numbers, but the domain would be whatever number it hits at, or a horizontal line, in which case the domain would be all real numbers, but the range would be whatever that one number is that it's hitting on the Y. So anyway, last thing, what if you got a bunch of dots? Well, in this case, there is one like this on the practice, and there is one like this on the one you do on your own. So I hope you watch this, or at least come to the live meet, because when it's dots, it's discrete different pieces of data. This is called a continuous graph because you can draw it continuously without picking up your pencil. This is called discrete, meaning there's like a distinct data point. There's different distinct data points in discrete graphs. So in this case, for domain and range, for domain, first off, function. Well, if you look right here, boom, vertical line touches 2 points. Nope. Not quite. Okay. So when doing domain and range for this, what I recommend is to write a table of all the points. So you can, because what you're actually going to do is you're literally just going to list your X's and Y's. Okay. And it's much easier to make sure you don't forget any if you do make a table. So every time I write down a point, I'm going to cross it off so I don't do it twice and waste my time. Anyway, First point is the point 10, 20, because all points are written x, y. Then I got 10, 40. That's this point. 20, negative 30. 40, 10. 60, 10. And 70, 40. Okay. So I'm just going to list all my x and y's, but here's the thing. You don't want to repeat yourself, and you want to go from least to greatest. Now, because I did my points from left to right, my x's are already from least to greatest. I just don't need to write the 10 twice. So when I do make a list, what you're going to do is you're going to use something called braces. It's like those fancy squiggly parentheses. And then I'm literally just going to list my x's. 10, 20, 40, 60, and 70. I'm going to close them with braces. The braces let me know that this is a set of specific numbers, okay? That's what that notation means. Because like up here, when I said x was less than or equal to 15, it's all the numbers less than or equal to 15. Like all of those numbers are included on the graph everywhere because I never pick up my pencil. All the decimals in between those numbers, all the fractions, everything. On this one, it's not all the numbers between two things. It's just these specific numbers. Okay. So that was my domain. For range, I'm going to list my y's from least to greatest, and I have a couple things in there twice so I don't have to repeat them. So the smallest number I have is negative 30. The next smallest would be 10. And the next smallest would be 20, and then 40. And if you notice, I have a different amount of numbers in my domain range, and that's okay because some of them are repeated. So just be careful with dots. A lot of people still want to say between these two numbers, and that's not true because it's not all the numbers between them. It's just specific ones. It's a set of specific numbers. So that is domain and range. And cool, that's it. All right, have a great day, and I will see you at the live.